All right, our warm-up for today is using composition to determine if functions are inverses. We do that by using substitution, where we have the original function and a second function, and we're going to substitute one part into another and vice versa. So in order for us to make sure that the composition works, is that we have to do f of g of x needs to break down to x. G of f of x needs to also break down into x. And if that doesn't happen, then that means that they are not inverses of each other. Now, because we're using composition, there's another way of figuring out if they are inverses of each other. You take the easier equation here, switch x and y, solve for y again, and if you get the same thing over here, then you know that they're inverses of each other. However, with the directions that are said right here, we need to actually use composition to determine if they are good or not. So what I'm going to do is I'm going to use different colors for substitution. The first one, this function right here, I'm going to use blue. And the second function over here, when I'm plugging it in, I'm going to use red and vice versa. So with that, the very first part is I'm going to write out everything I know up until we get to x. So here I've got negative 16 plus, open parentheses. I know I'm going to plug this thing in here. So I'm going to leave space with parentheses, and then I'm going to divide the whole thing out by 4. So what's inside the parentheses should be 4x plus 16. So 4x plus 16. Then I'm going to figure out if I need parentheses or not, and reduce accordingly. So here, the parentheses aren't necessary. They're just there to put in the placeholder. So I'd have negative 16 plus 4x plus 16. The whole thing is over 4. I'm going to reduce the top part. The 16s cancel, and I'm left with 4x over 4. The 4's cancel. I'm left with x. This checks out. If it checks out here, it's probably going to check out over here, but we're going to make sure. So I'm going to start with the 4 is what we're given. I've got parentheses, and then I've got plus 16 on the end. So what goes inside of here is what's in blue, which is negative 16 plus x, the whole thing over 4. So what I'm going to do now is I'm going to take this 4, and I see that this 4 and that 4, they're going to end up canceling each other out. So that gives me negative 16 plus x plus 16 on the end. The 16s cancel, and I'm also left with x. So that checks out. So if they both check out, yes, they are inverses of each other. All right, so let's go to the next question. Next question again, this is going to be my blue part that I substitute into the red. And this is the red part that I'm going to substitute in for the blue part for the x's. So starting with what I'm given, I have 1/4. I'm going to open up my parentheses for the x, and I'm going to use what's red to go right inside of here. Throw in a square minus 3. And now we're going to substitute the square root of 4x minus 12 into the equation. Now we're going to reduce. When we reduce, we square a square root, the square root goes away. So that's going to leave me with 1 over 4 times 4x minus 12, then minus 3 on the outside. I'm going to use distributive property. So basically we're dividing 4 into each of these two numbers, which gives me x minus 3 minus 3, because this 3 gets carried down. Then I'm going to go ahead and combine like terms, and I have x minus 6. That does not equal x. So right now we know that this does not work out. Maybe I made an error somewhere, so let me try it the other way to see if I get something else. So starting on this side, I have the square root, it's already written in there. I've got 4, and then I've got a parenthesis that I've got to stick that into, and then minus 12 on the end. Let's go ahead and plug it in. That is 1/4 x squared minus 3. And now I'm going to simplify the inside of the radical. So here I'm going to need to use distributive property, and that's going to give me the square root of x squared minus 12 minus 12. I'm going to combine like terms. which gives me the square root of x squared minus 24. That doesn't break down, so I'm stuck. There's nothing more I can do with this. This does not check out because it needs to equal x. If it doesn't equal x, then you have the wrong thing. So this part didn't break down accordingly, so the answer for this one was no, they are not inverses of each other because it didn't satisfy these two parts right here. That takes care of our warm-up for using composition to determine if functions are inverses.